Dear students, we are going to the chapter-wise concept. The topic is the theory of equations. Now we are going to polynomial equations. In the previous videos, we already discussed the polynomial or expression. That means expression means it is in the form of just f of x. F of x taken as expression. Suppose if it is a linear expression ax plus b, second degree expression ax square plus bx plus c, third degree expression ax cube plus bx square plus cx plus d, like that. So these are the expressions are called polynomials. Now we are going to polynomial equation. If the expression is equal to 0, then it is called equation. That's why it is also called polynomial equation. Polynomial equation means it may be first degree equation, second degree equation, third degree equation, fourth degree equation, fifth degree equation, like that. These are all called polynomial equations. So first degree equation is called a linear equation, second degree equation is called quadratic equation, and third degree equation is called biquadratic equation. Third degree equation is called cubic equation, and fourth degree equation is called biquadratic equation. Now fifth degree, sixth degree onwards, we are going to the equation is called as polynomial equation. Okay, that's why now we are going to discuss the polynomial equation definition. Now let f of x be a polynomial. Let f of x be a polynomial. Then f of x is equal to 0 is called polynomial equation. Polynomial equation. That is taken as, that is a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on plus a n minus 1 x plus an is equal to 0 is called a polynomial equation of degree n, where n belongs to capital N. Degree n or nth degree polynomial of real variable x with real variable x, where a0 not equal to 0, a1 comma a2 comma a3 comma so on comma an are constants, and this equation has n and only n roots. The roots may be real or imaginary. The roots may be real or imaginary. The roots may be real or imaginary. That's all. So this is the formation of the polynomial equation. That means the polynomial equation of degree n, where n belongs to positive integers or set of natural numbers, where a0, a1, a2, so on, an minus 1, an are called constants. Constants. The constants may be real numbers or imaginary numbers, and this is the polynomial equation with real variable x, and this equation has roots. In the previous video, polynomial or expression gives zeros. That means we have to identify the values of x, which are called zeros of the polynomial. But here, for this equation, the values of x are called roots of the polynomial equation. That's why for nth degree polynomial there exist n roots. Whatever it may be, it may be real roots or complex roots. That means imaginary roots, real roots or imaginary roots. That's why the nth degree polynomial equation has n roots, n and only n roots. Okay, that's why this is. Now for examples. For n is equal to 1, it gives a0 x plus a1 is called first degree equation, or linear equation. Now, for example, 2x plus 3 is equal to 0. That implies x is equal to minus 3 by 2. Is the root of this equation? Is the root of given equation. Root of the given equation. Now, another example. That is, for in the expression, that means in the polynomial equation, for n is equal to 2, it gives a0 x square plus a1x plus a2 is equal to 0. So in this one, where a0 not equal to 0, here is called second degree equation or quadratic equation. Is called second degree equation or quadratic equation second degree equation or quadratic equation, where a0 not equal to 0 and a1 comma a2 are constants. Are it clear? Now, examples. For this one, x square minus 5x plus 6 is equal to 0. X square minus 5x plus 6 is equal to 0. Now we have to solve this. X minus 2 into x minus 3 is equal to 0. That's why x is equal to 2 comma 3. Therefore, 2 and 3 are the roots of the given equation. Roots of the given equation. That's it. That's why for polynomial or expression, so the values of x satisfy the polynomial are called zeros of the polynomial. Here, for polynomial equation, the values of x satisfy the equation are called roots of the equation. The roots may be real or imaginary roots. Real or imaginary roots. Now we are going to another example. Next example. Example, for n is equal to 3. For n is equal to 3, the polynomial equation is cubic equation. Now, for n is equal to 3. For n is equal to 3, then it is a0x cube plus a1x square plus a2x plus a3 is equal to 0 is called third degree equation, or cubic equation, where a not equal to 0, a1 comma a2 comma a3 are called constants. Now example for this one. Now example that is x cube minus 6x square, x cube minus 6x square plus 11x minus 6 is equal to 0. 11x minus 6 is equal to 0. X cube minus 6x square plus 11x minus 6 is equal to 0. So, this is the cubic equation. Now, so here, for x, put x is equal to 1, it will be satisfied. Put x is equal to 1, it will be satisfied. So, f of 1 is equal to 0. That means put x is equal to 1, then 1 minus 6 plus 11 minus 6 is equal to 0. By Horner's method, we have to find the remaining roots. That is 1 minus 6, 11 minus 6. Here is 1, 0, 1, 1 minus 5, 6, 6, 0. That's why here we get x square minus 5x plus 6 is equal to 0. Now for this one, x minus 2 into x minus 3 is equal to 0. That's why x is equal to 2 comma 3 and x is equal to 1 also. That's why x is equal to 1, 2, 3. For this one, x is equal to 2, 3 and here it is 1. That's why x is equal to 1, 2, 3 are the roots of the equation. That's why this equation gets 3 roots. 1, 2, 3. Are you clear? Like that, for n is equal to 4, then a0x power 4 plus a1x cube plus a2x square plus a3x plus a4 is equal to 0 is called biquadratic equation. Is called biquadratic equation or polynomial equation of degree 4. Polynomial equation of degree 4. Polynomial equation of degree 4. Example: x power 4 minus 5x cube plus 7x square plus 3x minus 2 is equal to 0. So it is one of the equations like that. Next, for n is equal to 5. For n is equal to 5, it is For n is equal to 5, it is fifth degree polynomial. Polynomial equation of degree 5, like that. So we have to find the roots. So for polynomial equation, there exist roots of the polynomial equation. For only polynomial or expression, there exist zeros. Are you clear? That's all. So this is the polynomial equation. Polynomial equation means if an expression is equal to 0, then it is called polynomial equation. Now, these polynomial equations are two types. Polynomial equations are two types. Now, polynomial equations are two types. Polynomial equations. Polynomial equations are two types. Two types. Type 1. Type 1. Real polynomial. Real polynomial. Real polynomial. Polynomial equations are two types. Type 1 is real polynomial. That means in the polynomial equation, the coefficients, that means in a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on plus an minus 1x plus an is equal to 0. Now this is the polynomial equation. In this equation, a0, comma, a1, comma, a2, so on, an minus 1, comma, an minus 1, comma, an are called real numbers, are real numbers and x is a real variable. X is a real variable. X is a real variable where a0 not equal to 0. A0 not equal to 0. Then the equation is called. Then the equation is called. Then the equation is called. Then the equation is called real polynomial. Then the equation is called real polynomial. Then the equation is called real polynomial. That means here a0, a1, a2, so on. These are the coefficients. What are the constants? If the constants are real numbers, then if the constants are real numbers, so then the polynomial equation is called a real polynomial. For example, 5x power 6 minus 3x power 5 plus 4x cube minus 2x square plus x minus 7 is equal to 0. Observe, 5 minus 3, 4 minus 2, 1 minus 7, these are real numbers. That's why it is called real polynomial. It is called real polynomial. Now type 2, that is a complex polynomial. Complex polynomial. Complex polynomial means what? A0, A1, A2 are called complex numbers. Complex polynomial means what? In the above equation, a0, comma a1, comma a2, so on, an minus 1, comma an represents complex numbers, then it is called complex polynomial. 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 Now example that is 2x square minus 3 plus 7i into x plus 4 plus 5i is equal to 0. Observe, here this is the second degree polynomial. Where minus of 3 plus 7i and 4 plus 5i represents complex numbers. That's why it is called complex polynomial. That's why polynomial equation. That's why in the numbers, polynomial equations are two types involving the constants are real numbers. Then the polynomial equation is called real polynomial equation. That means the constants are complex numbers. Then the polynomial equation is called complex polynomial or complex polynomial equation. No problem. Real polynomial means it is not equal to 0. Polynomial equation, real polynomial equation, suppose if it is taken as equation, no problem. It is a complex polynomial equation, it is a real polynomial equation. Okay, that's all.